Improving communication, integrating voice and vision with language models. Language models have opened new horizons for us, but let us improve our interactions with these models by integrating, let's say, voice functions. Voice technology does not only make digital content easier to manage, but also improves the user experience. And by integrating automatic speech recognition (ASR) and text-to-speech functions (TTS), we can create more natural and engaging interactions. As usual, let us download the modules and get started, and then use transcription to recognize the speech from an MP3 file.
Well, the mother says we had to go anyway. We hadn't much a choice in the matter, but sure.
It's a cold journey to school this morning.
Oh, good, you wouldn't be long getting frostbite.
It's nice to look at, but tough to live in, and there's no respite yet. Tonight, weather warnings remain in place right across the northwest. Garth Wilkinson, UTV Live, Derry.
As you can see, transcription allows us to quickly recognize speech, even with, let's say, challenging accents like the ones in the audio file. We can also translate. Let us try with a Japanese audio file.
ところについて、はい、お聞きしてるんですけど、日本のいいとこ？はい、思う日本のいいところ。
Nice, eh? By integrating Whisper from OpenAI, we can show how technology can simplify complicated tasks and provide this speech-to-text result in a matter of seconds, which can then be used by language models to support a variety of applications, from creating summaries to enabling interactive learning platforms. The latest investment by OpenAI in text-to-speech technology recreates our expectations for the quality of artificial sound. These models have made huge progress in creating more realistic sounds than ever before. Let us try with a clip from Homer's Odyssey.
Tell me, O Muse, of that ingenious hero who travelled far and wide after he had sacked the famous town of Troy.
Tell me, O Muse, of that ingenious hero who travelled far and wide after he had sacked the famous town of Troy.
Pretty cool, eh? We can also include image recognition with our application. Let us look at this example. Here, rather than adding our usual user prompt, we have a different prompt that allows us to put a list where we would have text and then an image. As you can see, we can get a detailed description of the image, and this image may be a link or an image that has been downloaded and represented by Base64. Now let us try another example that might excite you and scare you at the same time, I don't know. With the use of some behavioral guideline, we will download the video and use the large language model to provide narration to a blind person. We take it, we grab a couple of frames from that video and include it in our prompts. And as you can see, the model considered its prime directives to provide a detailed explanation of the person's so-called view and gave instructions on whether it was safe to cross the road. The implications of this are enormous, and the best thing about it is available to everyone. We also got the response in speech, which coupled with ASR would make it a complete solution for someone that cannot read or write.
It looks like you're near a street corner in an urban area during the day. There's a pedestrian crosswalk in front of you with a don't walk signal illuminated, indicating it is not safe to cross right now. Several vehicles are in the roadway. Some are moving and some are stopped, waiting for the traffic light, which is